I find really
Any
dumb things funny.
any chemistry joke.
Not any of them.
No,
Yes.
some of them are funny.
If it
All right.
involves a pun and chemistry.
Do you have a calculator?
joke?
Yes.
Yes. Okay.
Hey, good job.
What is an what is an isotope? Raise your hand,
I
please.
got you.
Go ahead, Marlena.
Two atoms of the same element with the same number of protons but with a different number of neutrons.
Good. Two atoms, same number of protons, different number of neutrons.
Yeah.
Thanks. Appreciate it. All right. So, did I give you these three yesterday?
Yep.
Yeah.
Did we label the number of neutrons?
Yeah.
We did?
Yeah.
All right, let's review. How many neutrons here? Zero. How many here? How many here?
Two.
Good. So, remember, inside the nucleus, what's contained there? Protons and neutrons. So this one would have one proton, one neutron, or one proton, zero neutrons, one proton, one neutron, and one proton, two neutrons. The concept here is that the nucleus for all three of these are different because of the neutrons, not the proton. The protons have to be the same. Why? Because it's all hydrogen. Did I give you the carbon examples?
You gave us the example. You gave it, but we didn't write it.
Okay. So carbon 12, 13, and 14. So carbon 12. By the way, what do these numbers represent? Are they mass numbers or atomic numbers?
Atomic mass.
Well, here's the nuclear symbol, 12 over 6, 13 over 6, 14 over 6. So they stand for mass. Very good. So you might see this on your quiz Thursday. Wink, wink, nod, nod. Okay?
That was really subtle.
You might see that. And on the regents, that's really common. They don't always give you the notation, the nuclear symbol. Sometimes they just give you that. So it might say, given the following, that, how many protons and neutrons does that have? So you have to be able to convert that yourself from here to that. So that's why I'm writing it that way, so you can see both options. But that's the mass number, okay? That's always going to be your mass number. So, how many neutrons here? 6 neutrons. Just subtract. How many here? 7. How many here? 8. Good. That's why these things are isotopes. They are the same exact element because they all have 6 protons, but the neutrons are different.
I
Now,
thought it said 72.
I did too.
And I'm like, that does not equal 6.
where?
12.
I thought
12
also
on
said
the-
70.
yeah,
I wrote
yeah.
70, so it was 13 and 14.
All right, well, we're at 12 there, sorry. What was I saying? Oh, right, these are isotopes because different number of neutrons means the mass is different as well. Now, where do isotopes exist? Okay, actually, we could use this as an example.
Wow.
Does this have organic material in it?
Probably
Do you know what organic means?
Not.
Something with carbon. That's really all it means. In chemistry, that's what it means. Something with carbon. Yes, this has something with carbon. Chocolate has, I'm assuming there's some real chocolate in here. So there's carbon in here. Chances are, all 3 of these isotopes, mostly these 2, are going to be in here. Everything that you come in contact with has a mixture of different elements, and not only different elements, but different atoms of the same element. So banana, I had a banana here, there's some over there, right. The banana, what do people eat bananas for?
Delicious.
Well, they taste good, they're good for you, but what's in it?
Potassium.
Potassium, right. Potassium has 2 or 3 isotopes. All of the isotopes are in bananas. What?
You can't hear my jokes back here. I have a really funny one.
Go ahead.
You said, what do people eat bananas for? And I said, anaphylaxis.
Oh,
Because I'm allergic. If I eat it, my throat will close.
that is funny.
That's really funny.
Is it okay that they're there?
Huh?
Is it okay that they're there?
Yeah.
Okay. All right, so that was funny.
Thank you.
All right. So anyways, the concept of isotopes, they're all over the place, okay? If you have a sample of something with carbon in it, these all are there. And in potassium, or a banana, you have potassium. All of the isotopes are in there. But here's what you need to understand. The decimal point masses on the periodic table, where do they come from? So, write this down here. The atomic mass, and then I'll give you some examples, is calculated by taking a weighted average. Make sure you write this word for word here. Weighted average of an element's naturally occurring isotopes. And the most abundant isotope is the one with the mass closest to the mass on the periodic table. Sorry, I got down near the bottom here, which is annoying for me as well. So write all that down, then I'll explain. I want to look it up anyway, so I'll give you accurate information. I don't know the isotopes of potassium off the top of my head. Okay. We all got this stuff written down?
Yep.
Okay. So I need to explain this. Bottom one first. The most abundant. What does that mean? Most abundant.
Most of the.
A lot of it, right? There's the most of that one. Okay. There's a lot of it. Okay. The most abundant isotope is the one with the mass closest to the mass on the periodic table. So look to the right. Look at potassium. What is the mass of potassium?
39.
Whole number would be 39, right? Look up here. You have two isotopes that are stable for potassium. I just looked it up to make sure. K41, K39. Which one, according to what I just wrote, is the most abundant?
Okay, 39.
39 right here, okay? Now, if you have a banana, and you were to analyze that banana somehow, and you could figure out how many atoms were potassium 39, how many were potassium 41, most of them would be K39. That's what I was trying to explain. I know it's hard to understand all of this and visualize it, but if you have a banana and you can somehow use chemicals and equipment to analyze the amount of potassium in it, most of the potassium would have a mass of 39. Some of it would have a small amount, mass of 41. That's why I use these magnets to help you visualize a little bit. Let's say you have 10 atoms. 8 of them would be this one, and then 2 would be this one. This is obviously more abundant because there's more atoms. That's why I put them up here. Now, questions? Someone's going to say something? Annika, you good?
I'm fine.
That wasn't you? Okay. So if we had 10 atoms, what is the percent abundance of K39? Out of 10 atoms, what percentage is K39? 80%. 8 out of 10 is 80. What about this? 20%. So again, another way to explain most abundant. So if you look over here at all these elements, let's say I'm looking at boron. Okay? You have 10.811. What does that round to? 11. So if I had two isotopes, look up here. If I had boron 11 and boron 10, which one's more abundant?
Red.
11, because that number is 11 up there. Okay? What about back to carbon? 12, 13, 14. Oops. Which one is the most abundant?
12.
12. Why?
Because it's closest to the
Because the
mass.
mass is 12. Okay? I know chlorine has two. Cl35, Cl37. Which one's most abundant? 35. 35. Why? Because that mass is it's closer to 35 than it is 37. So this is actually really important to understand, not just to understand the chemistry, but on the Regents question, they ask that sometimes. Which of the following isotopes are most abundant? They give you four choices, let's say. and you pick the one that's closest to the mass on the chart. So that's the easy part here. Okay, here's the harder part. I'm going to erase this though, because I need the board. Okay, what does weighted average mean? Who would like to explain that?
Yeah, you add them all up, and then you divide by the number.
Add them all up, divide by the number of numbers you have.
Yeah,
Do some of them count more?
That's not weighted though.
that's just the average.
Some count more. I like to use an example to help you understand this. Who are we going to use?
Me,
Let's use
Kieran Handler.
Trevor.
No, not Trevor. Couldn't want Kieran Handler.
All right. So in this class, you have homework grade, quizzes and tests, and you have lab. Okay. Trevor, what do you think your homework average is?
I don't know.
Guess. Like 90, 95?
Sure.
You basically do all your homework. Let's give him a 90. Good job, Trevor. What about quiz average, Trevor?
102.
102. Can we keep it under? Can we just say 100?
Sure.
Yeah, I don't know. I don't think it's 100, but we'll go with the example. It's just for fun.
It's 100.
All right. Now, what about your lab average? What do you think? 45. Sounds good. Okay. All right. Trevor's not a very good lab student. All right. No, his lab average is probably 80s, 90s. We know Trevor's a good student. But what am I trying to explain here? Well, in this class, your homework average is worth about 15%. Your quiz average is worth 60%. And your lab average is worth 25%. I think that's how I have it set up. This might be 55, that might be 20, one of the two. But do these numbers add up to 100?
Yeah.
Yeah, okay. So, I need you guys right now, and I want to see how you do. Tell me, what is his overall average? If he has a 90 for homework, which is worth 15% of his overall grade, he has 100 for quiz average, which is 60% of his overall grade, and a 45, just not a good lab student, and that's worth 25% of his overall. I want you to write one number down. What is his overall average? Round it to a whole number, circle it. I want to see what you get. So,
I don't know.
if you don't know how to do it, then that's okay, but try. Give me something.
Oh, I can't do this.
All right. Well,
Because this is how you do a weighted average, and this is how you're going to learn how to do the chemistry part.
You gotta divide that.
This is a good question. That's what I kind of.
It is a question. I want to know his average. So, Amber's here.
This is so. That's definitely wrong.
Okay, I'm just taking a wild guess.
Well, let me ask you guys this question. What's his lowest grade?
45.
What's his highest grade?
100.
Okay, so the average should be somewhere in between then, right?
Yeah.
You don't like Trevor?
No, I wanted to use
I don't know
all.
what's. How'd you do it? Hey, Drew, what did you
I did it really weird.
67, 47, so I did it wrong.
Yeah.
Yeah, I didn't know that I did it right.
Something.
Okay,
That's
so
something
no.
okay.
You're thinking, okay.
Yes.
That's your number? Where's your number? You're supposed to have a number for me.
Dude, I got you a number right there.
Where's your number?
Dude, I'm
All right, that's fair. All right, so I saw 78 and 83
I got 94.
as the and a 94.
Yeah, I know.
Would one of the 83s or 78s want to explain how they did it?
More than one person.
to be honest, mine was actually a complete guess.
Go ahead.
I just added up all the grades and then I divided by 3 and then
That's the average. That would work if all of these were weighted equally. So if this was 33, 33, and 33, that's pretty much 100, 33.3.
99.
So that would work. But for this, we need to take the percents into account. So thank you for volunteering. That is the right way to do the average, but we want to do a weighted. So what do?
I don't know.
We take the percent and multiply it by the number.
I divided it.
Wait. But first, you can't use the actual percent, because that's not the real number. You have to use 0.25, 0.6, and 0.15. So here's how we do it. Here's how we do it. We take 90 times, is this on the screen?
Yeah, I think. Well, that part is, yeah. Just don't go any further.
How do you do, students that are missing class?
Alright. Okay, up here, focus. 90 times 0.15.
Wait.
11 point what? 11.25.
Yeah.
Okay. 100 times 0.60.
Can you give him an answer?
Amanda's sabotaging me.
Sorry, and that's
It's all right.
60.
60. And then 45 times
Yeah, that's
0.25. That's 11.25? Okay, now look up here. Really pay attention, because this is how you're going to learn how to do the chemistry part. You take the percent, make it a decimal. That's easy to remember, I think. Then multiply it by whatever the number is associated with that percent. So 15% of 90 is 13.5. 60% of 100 is 60. That one was easy. 25% of 45 is 11.25. So, eyes up here. This number is 25% of Trevor's grade. This is 60% of his grade. This is 15% of his grade. So if I add these three numbers up, what am I getting? 100% of his grade. So if I add these numbers up, what does that equal? 84.75. So that would round to an 85.
I was
Yeah, 85. Okay. So the reason, stay with me, the reason I take time and use like a real example, this is how the grading program does it, is so you can understand something. You understand grades. You get this. You understand things are worth more in school. Now you have to relate this to isotopes. So I'm going to give you exact same concept, just in the chemistry terms. So here we go. Write this problem down, please. Your work is going to be the exact same. Percent times the number, and then add them up at the end. So here we go. Calculate, write this down please, calculate the atomic mass, because this is how all the atomic masses are calculated up there, at least the ones with decimal points. Calculate the atomic mass given the following. Here we go. The isotope, the atomic mass, and the percent abundance. Okay, the isotope is, and we're using Cl here, Cl35 and Cl37. The actual mass of a Cl35 is 34.969 AMU. The actual mass of a Cl37 isotope is 36.966 AMU. And AMU just stands for atomic mass unit. It's just a unit. And percent abundance for 35, it is 24.23%. And the other one is 75.77%. Nope, I did that backwards. Sorry, my fault. Flip those, sorry. 77 or 75.77% here. And then 24.23%. Sorry about that. All right, so there's your percent. There's your mass. You're going to do a weighted average of these numbers here, and it should equal 35.45. That's how you double check yourself. You can do the math and then check it. So I need you to show me the work and show me how to get the atomic mass. It's exactly like we just did with Trevor's average. The exact same thing. Take the percent, turn it to the decimal, multiply it by the number, then add the 2 at the end, and then you're good to go.
Wait, what decimal do we change? The atomic mass? Right?
No, the first one.
Well, percents
Oh,
aren't,
yeah.
aren't real numbers, so those are the ones you have to change.
But
Oh, I
you already
forgot.
have it. So do you just move it?
Yeah, that's the percentage, which is not a real number. So you
Yeah.
have to move it to get the real number.
Okay.
So I'm gonna come around and check. Make sure you got something written down, right, Nick?
And then
What do we round to?
Round to the hundredths. Good question. Yeah. But
thank you.
Trevor, you had this homework done, right?
Yeah.
Okay. September.
What did those get? 35?
You're supposed to get 35.45.
I did.
I got 35.5.
See that? See that?
You did not follow directions.
You see that?
Supposed to round to the hundreds.
Well,
Wait,
this
this
was
was
point
point
Yeah.
nine. What do we do?
Really?
I mean, unless I just round
Wait,
it wrong.
see it.
Maybe
I
I
bet
did
it's
wrong.
26.496. Where do we round?
You put it
Would that just be 26.9?
Here. I did, yeah,
Round
26.5.
Yeah. Yes.
And then, would the
Well,
next one be
if so-
round to 9?
If your intermediate steps, you can keep all the decimals and then round to the hundredths. That's listen. If you got that, you're good. You're on the right track.
Did I? Well, I got exactly 35.45.
How come there's
Wait.
minus on it?
It does not.
It says minus on top, doesn't
It
it?
says memory.
No. it doesn't minus.
Memory.
Be a minus for it.
Minus.
How's it going for your morning? Peachy?
Guys.
And then,
It's a Tuesday. Does anyone have family members that say that? Tuesday?
what?
Monday? Wednesday? Yes. The funniest one
No, I always
is
think
Saturday and Sunday.
Okay.
My grandma says it.
Yeah. I used to know, well, I do know the guy, but I haven't seen him all the time. Just that when he talks, he'd always say Saturday and Sunday. I was like, I don't know what that is. Is that same day, Saturday? Is that
Sunday.
all right. Kind of funny. I think when I get old, I'll talk like that. Here we go. Now, what do we do?
Well, you gotta multiply that times 0.757.
Go ahead. Go ahead, instructor. I understand. I'm not yelling at you.
Oh, Morgan?
I don't really want.
No, go ahead.
No,
I heard you. So we're gonna take 34.969 and multiply it by what?
76.
Close. Point.
I rounded off.
Don't do that.
I got 35 though.
I got 35 minutes.
It's okay, but try not to do it in the future. So we move this to the left. 0.7577 times the mass. What do we get?
Oh, I put my
Annika, give me all that, Jazz.
26.49.
26.49. So she rounded to the hundredths because that's what I said, so
Oh,
that's
that's
fine. That's fine. Now, we take this mass, 36.966 multiplied by 0.2423. We take the mass multiplied by the percent. Mass multiplied by the percent. Then we're going to take these two numbers and add them together. This is called the weighted average. What did we get here?
9.
8.8? No.
9.6.
8.96. Yes?
Yep.
Okay. Now we add these numbers together, and it should be 35.45 or something pretty close to that. 35.45 is what we should get for the atomic mass of Cl.
Now, if I got 35.5, would that be like long?
No, you're fine. Questions for me? What if I gave you 3 isotopes?
Do the same thing.
You would do the same thing 3 times. So you would take the mass times percent, mass times percent, mass times percent, add up your 3 numbers, and that's how you get your answer. On the worksheet due tomorrow, the back of this business here, it's only 2 isotopes, just like this example. All right? But if you're going to get this on the regions, this is how it's going to be. Okay? Your quiz Thursday, I put at least one of these on there. Okay? So this is due tomorrow. Don't forget that other sheet. Before we wrap it up here, I'm going to write a question on the board. Good review question. I forgot I was going to put it in the early beginning part. Write this down. What is the nuclear charge
What
on
is
an atom of silver? Don't say it out loud. Write it down, please. Good review question. I should have had it up there in the beginning. Just didn't do it today.
nuclear charge?
What is the nuclear charge on an atom of silver?
Well, can you at least tell me which one is silver up here?
No.
Is it AG? No.
That's almost gold.
Yes.
So correct.
What? Oh yeah. it
So
is.
what, Karen?
What?
So what?
So correct.
Wait, is that? That's such a good way to remember it.
Isn't that what I said?
Yeah, that's what
Yeah.
you said.
Oh, maybe
I wasn't
you
here,
missed
okay?
a little bit.
You were
Listen,
in
I learned the
Zululand.
periodic table in like a night.
You were a
Why don't you just-
coach.
Cut you some slack. Yes, okay, it's AG. The answer is AG, but what is the nuclear charge since we're discussing it and I didn't want to?
47.
Plus 47, why? Nuclear charge is the number of protons, right. The more of you that remember that, the better off you will be. All right, so we can pack it up, but I want to go to, where is it? The worksheet I just handed out to you guys. Oh yeah, bring out the calculators.
Oh, I'll collect them all right here. Put them on in there. Oh, yes. Oh, yes.
Stop. Whatever you're doing. Stop. All right, this video's over.